Hey guys, welcome back to the continuation of organic chemistry. If we are looking into our previous videos, we can check this thing that we are done with the two properties of alkanes. Number one property of the alkanes were combustion, which we are done with, and the second property was cracking, which we are done with as well. So two of the properties we have practiced. One of them is property is cracking. The other is combustion. I have just mentioned we are completed with them. Right now I'm going to start with the third property of alkane, and that is called as substitution reaction. Okay, substitution reaction. Guys, before moving ahead, I would like to bring your attention to a point. When you people will be in your AS level, there we are going to take the name nucleophilic substitution reactions. Okay, substitution reaction. Now, what is the difference between nucleophilic substitution reaction and substitution reaction? Before moving ahead, I would like to bring your attention to the point that nucleophilic substitution reaction will involve the mechanism, the way, the process, the actual way in which reaction is happening, the details, the explanation. All the process will be very much enlarged and long, and it is with complete details and description. But right now, what is substitution and nucleophilic substitution are basically the same. But in case of nucleophilic substitution, we will take you towards more depth. And in case of substitution reaction, it is just the basics of substitution. Okay, now what is substitution reaction? Just recall that time when you people were in grade 3, and if one teacher was not there, oh, that's a happy day, teacher is absent. Oh no, a substitution teacher. Yes, a substitution teacher is there. Okay, so substitution teacher was not the teacher for that class, but she or he is just replacing the teacher who is absent on that day. Okay, so it is just the replacement, a substitution, a process in which one thing is taking the place of another thing, a person is taking the place of another person, etc., etc. So this is what substitution is. Right now, for example, we are just saying in this case an alkane is there, and alkane is going to react with a halogen, and as a result of that, a substitution reaction is going to happen. And what is the product? A halogenoalkane, and along with that, a hydrogen chloride, a hydrogen halide is a better word. Hydrogen halide will be formed. Okay. Now, there might be some new terms for some of the students. What is halogenoalkanes? It is also called as haloalkanes or halogenoalkanes. Details of halogenoalkanes we are going to teach you in AS level, but right now I'm just telling you what is halogenoalkane. Am I going to teach you AS right now? No, no, no. So what's going to happen? I'm just going to bring your attention to the basic point. What is a halogenoalkane? A halogenoalkane is an alkane having one halogen attached with it. Along with the halogenoalkane, a hydrogen halide is formed as well. What is a hydrogen halide? It is a combination of hydrogen with any halogen. Remember, what are halogens? Some of the students are keeping that thing in their mind right now, I know, but might be some of the students are forgetting what is a halogen. Halogens are the elements of group number 7, which is also called as group number 17 as well, if you are recalling that concept of transitional block counting, which I have told you when I was teaching you the chapter of periodic table. Okay, you people can look into that video of the periodic table. Okay, now what are the halogens? I am just writing the list of the halogens right now. It was fluorine, chlorine, bromine, iodine, astatine. Okay, there is a new element below astatine as well, called tennessine. But in most of the periodic tables, you people are going to look into these elements. But I'm sure the new periodic table, which you will get in your Cambridge examination, which will be attached with your MCQ paper, and which will be attached with your theory paper as well, that will be included including the tennessine element, which is after astatine. Okay, so these are all the elements which have 7 electrons in their outermost shell, and they are going to make a covalent bond with hydrogen, and that is called as hydrogen halide. Combination of hydrogen with any of them is called as hydrogen halide. Okay, now we are going to look into the details which are related to your syllabus 5070 and 0620 currently. Okay, now the point is this, that when we are looking into substitution, it is a continuation of substitution. We are going to make the practice of substitution reaction as well according to your syllabus. Okay, there is one point which you should know, and that is called ultraviolet radiations of sun. Okay, now there is a thing which you should know, that this reaction of substitution with alkanes is requiring one very important factor, and that is called as availability of ultraviolet radiations. Okay, if ultraviolet radiations are available, this reaction is going to happen. If ultraviolet radiations are not available in the dark, it is not going to happen. So sunlight is important. You may say ultraviolet radiation source is important. We can carry out this reaction in the lab as well, as far as we are having an ultraviolet radiation source available with us. Okay. It is a stepwise reaction. I am writing this as well. It is a stepwise reaction. What is the meaning of stepwise reaction? In each step, a hydrogen of an alkane is being replaced by a halogen, and the number of steps are based upon the number of hydrogens present. Okay, so stepwise, and I'm telling you, number of steps are equal to number of hydrogens. Okay, number of hydrogens. Okay, now the point is this, that these are the points which are important regarding this information of substitution. I'm going to carry out one of the example right now. You can look at this. What is this? This is called as CH4. It is an alkane, and what is the name? It is called a methane. Okay. Now, many of the students might be thinking, if they have not looked into the previous videos of organic chemistry thoroughly, they might have this confusion, how I will know this thing that it is a methane. Okay, now it has only one carbon atom, which is called as meth. Yes guys, I am bringing your attention back towards that concept. When there is one carbon atom while studying organic chemistry, it is called as meth, and it is following the general formula of alkane, which is CN H2N plus 2. That is the general formula for alkanes. It is telling you that it is methane. Okay, now depending upon the structure, I am going to write down the structural formula of methane. What is the structural formula? I'm bringing your attention towards that concept again. Structural formula is that formula in which all the bonds of all the atoms are shown. It is also called as displayed formula. Might be examiner is asking the name of displayed formula or the structure formula for any organic compound, and you people are supposed to write it like that. Okay. I am writing the first case right now. You people can see this thing, that here I am writing Cl2. What is Cl2? It is a halogen which is called as chlorine. Why I am writing Cl2? Why I am not writing Cl? Remember this thing guys, Cl2 or all the halogens, and along with halogens, oxygen, nitrogen and hydrogen are naturally diatomic. What is the meaning of diatomic? Diatomic means when an element is in the form of two atoms. Okay, when two atoms are together for an element, it is called as diatomic. Okay, so right now I'm going to make the molecule of this molecule. Why I'm going to say it molecule? Because it is a combination. It is a chemical combination of two or more than two non-metal atoms with each other. Okay, so non-metal atoms are combining with each other. If they are similar, that is called as a molecule. If they are different, that is called as a molecule as well. But I have taught you in the initial videos that whenever there is a molecule of similar elements, it is called as molecule of elements. And then if there is a molecule of different elements, it is called as molecule of compound. Right now it is Cl2, and what is the formula here? It is C here, it is one Cl here, it is H here, it is H here, and it is H here. Guys, can you look at this right now, that only one hydrogen has been replaced. Only one hydrogen has been replaced in this case. Okay. Along with this, there is another product, and that is called as HCl. Guys, out of these two Cl atoms, one Cl atom is there, and along with this Cl, this replaced hydrogen is making a bond, making HCl. Now there is a big question. What is the name of this compound? This compound is called as 1 chloromethane. 1 chloromethane. Okay. Now the point is this, that why there is one. Okay. Guys, whenever we are going to number the carbon atom of organic compounds, we should know this thing, that numbering is very important. Whenever the naming of organic compound is concerned, we have to find out the number of carbon atoms. That is called as what is the length of the carbon chain, how many carbon atoms are going to combine with each other to make a carbon chain. Then according to that, we are going to give the numbers. Here there is only one carbon atom, and that carbon atom is considered as number one. On that carbon atom, it is just the chlorine, so I'm saying 1 chloromethane. Now might be some of the students are thinking this is no more methane. Methane was formula CH4. That's why teacher is calling it this methane as well, although one of the hydrogen has been replaced. Guys, please look into the fact that it has only one carbon atom. So whensoever there is only one carbon atom, you are going to call it at meth. Okay, so that is called as meth. And why ane? Because there is no other thing attached with that. When you are going to pursue the organic chemistry lectures with me, inshallah, you people will get this thing, that there are many other points which are clarifying this situation, and they are going to tell you that it is an alkane and why it is not something else. Oh, so right now I have just explained this thing in detail, that one means the position of the halogen with the carbon atom. So this chlorine is attached on position number one. This chlorine is attached on carbon number one. Carbon number one means position number one. Carbon number three means position number three. So they are interlinked with each other in detail. So this is called as 1-chloromethane, and it is HCl along with that. Okay. Now, guys, I am just telling you one more thing. That is the key point basically, that product of step number one is acting as reactant of step number two. Product of step number two is acting as reactant of step number three. So it is just like this. This is this, and this is this. This is this, and this is this. Okay. I'm making it like this, and this is this. Okay. And now I am bringing your attention over here. This is this. So product of step number two is acting as a reactant of product of step number one is acting as a reactant of step number two. Product of step number two is acting as a reactant for step number three, and so on, so on. Okay. So this is how it is happening in case of substitution reaction. Mostly examiner is not asking you to write down many of the reactions, but there is a possibility that examiner is asking for the substitution reactions of methane. Why it is so? Because it has only 4 hydrogens. So how many steps will be involved? 4. I have just told you on the previous page that total number of steps of substitution are equal to the total number of hydrogens present. So right now I'm just telling it to you that here I am going to take this product of number one as the reactant of number two. Okay, I'm going to rub this so that I may get a space over there. Okay, now I am taking it with the red color. You people can see this thing. This is Cl here, and this is H here, and H here, and H here. So it is just the same, 100% same, along with Cl2. Okay, now there is another question. How many Cl2s are there? How we will know this thing that Cl2 will be available? These type of the reactions are mostly happening in the upper region of the atmosphere, where there are many molecules of halogens available, and we just consider this thing that free availability of halogen molecules are there. That's why this reaction is happening. Okay, so that's why whenever you are going to carry out such type of reactions of substitutions of alkanes, you should know this thing that halogens are available in the diatomic form, and every time you are going to take a new molecule of halogen. Okay, so right away, what will be the product of this? It is just this C, and this is Cl, the previous one. Guys, I'm going to write the new one with the blue color so that you people may be able to differentiate. Okay, and this is H here and H here. Along with that, definitely one H is being replaced and one H is going to attach with the remaining Cl. Along with this product, the major product, what is produced, it is HCl again. Oh, so every time HCl will be formed as well? Yes, every time HCl will be formed. Okay, now I'm 100% sure that many of the students have got the 100% idea. Well, let me wrap it up before moving towards the further details till now. Number one, It is a stepwise reaction. Number two, number of steps are based upon the number of hydrogen atoms present. Number three, number of times halogenoalkane will be based upon the number of steps only, number of steps as well. If there will be four steps, there will be four times Cl2, Cl2, Cl2 attaching as a reactant. Four HCl, 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 HCl will be formed. So overall, how many HCls are being produced? Four HCl. So we are going to look into this. Can we say this thing that HCl is the inorganic product, whereas halogenoalkane is the organic product of this reaction? Keep this thing in your mind because this is an answer of a past paper question. Okay, so I am going to write the name for this. What will be the name for this compound? Now this is 1,1 dash dichloro methane. Okay, so there is a big thing here. Okay, now there is 1,1. What is the meaning of 1,1? Means that one at position number one there is one chlorine, at position number two there is second chlorine. So 1 means position number one, again position number one. So we are so we are just considering one chlorine and other chlorine at position number one. So this carbon is position number one. This carbon is the basic thing. Okay, so I'm just telling you 1,1 dash di. Why there is a word of di? Di means two chlorines are there. Dichloromethane. Dichloromethane. So this is how it is happening. 1,1 dash dichloromethane. Okay. Now this will act as the reactant for step number three. I'm going to change the page so that you people may have a clear idea again. Guys, look at here right now. So this was the product of step number two, and this is the H here and H here along with Cl2. Oh, again Cl2. Yes, I am writing here so that we may be able to get more space here. Yeah, you look at here right now. So this is Cl, Cl, and I am going to write the new Cl with the blue color, and the remaining H is along this, and this is HCl. You can see this thing that in this case, the third hydrogen is being replaced. So we can see this thing that this is a new name. Many of the students, I'm sure, are getting the name right now. It is 1,1,1. Why 1,1,1? Because at position number one, at position number one, at position number one, three chlorines are there. Dash trichloromethane. Okay, so this is the number two and number three now. Okay, now this is the point that what will happen in the next. Okay, guys, can you look at the right now? This bigger arrow is just telling you that it is just the product of number three, which is acting as a reactant of number four. Here I am going to take it like this. It is the this, it is this, and it is this. So three of the chlorines are already there, and this is H here, and it is going to attach with Cl2 again. Yes, along with this, guys, this is now Cl, 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 and Cl. Along with this, it is going to make HCl. Oh my God, what is this? Yes, this is a very last compound. And what is the name of this? Guys, can I say this thing as CCl4? Yes, I can call it as CCl4 as well. If I'm calling this as CCl4, can I call it CHCl3? Yes, I can call it CHCl3 as well. But can I write it like that? If examiner is asking for the displayed formula, then definitely you have to go for this one. If examiner is asking for the molecular formula, this is the molecular formula. Okay, so please make a difference between the two. And once you are going to make the practice at the start of the substitution reaction, it is highly advised to make the practice with the structure formula, because structure formula will help you that each of the carbon atom has to make four bonds always. Each of the halogen atom and each of the hydrogen atom have to make always one bond. Okay, so these are the basic points which you can understand while drawing the displayed formula or the structure formula only. If you are going to make a practice with the molecular formula, things will become problematic for you. It will remain a confusion to attempt, and maybe it is causing a problem right from the beginning. Okay, so I'm just suggesting all of you to make a practice with the structural formula. Okay, now what is this right now? So it is CCl4, and what is the name? It is one. Oh, I am going to make it with a pen. Okay, it is 1,1,1 dash tetrachloro tetrachloromethane. Okay, so this is the name of this compound. Okay, along with this compound, what else has been produced? It is HCl. Okay, it is HCl. Now these are the points which you should know this thing, and you should know how to write. I'm going to write down the name for this, the formula for this as well. CH3Cl. Okay, CH3Cl. And what is the name for this? CH2Cl2. Okay, so I can say this thing dichloromethane, or you may say chloromethane, trichloromethane, tetrachloromethane. Okay, so carbon tetrachloromethane, or you may say carbon tetrachloride. This is also called as regularly we are called as carbon tetrachloride. Carbon tetrachloride. Okay, but which name I should know? Guys, I'm suggesting all of you that you people need to keep both of the names in your mind. For the organic chemistry, for the substitution reaction, for the exact naming, I would like to suggest you very perfectly this name is the exact name for the organic chemistry, for the substitution reaction, etc. But this name is the bottom name. This name is basically we are going to write when we are practicing generally, when examiner is asking that carbon tetrachloride is the product, so you are going to write it CCl4. Okay, so these are the points which you people should know. These are the things which you people should keep in your mind, how they are going to work. Okay, now I am going to change the page and going to take you to another example so that you people may have a better idea regarding this. Okay, so here I am telling you very clearly that alkane, okay, alkane is going to react with a halogen, and here I am writing what is the product: halogenoalkane, halogenoalkane. Along with halogenoalkane, the other product is hydrogen halide, hydrogen halide. Okay, guys, let me inform you very clearly that and this is are different type of the things which you should know. So what is this? This is organic in nature. This is inorganic in nature, inorganic, and this is inorganic in nature as well, whereas this product is organic in nature. So these are the points which you people should keep in your mind. Right now, I am going to bring your attention to the next one, and that is called as ethane. Okay, let's consider ethane. Ethane is reacting with fluorine, for example. Guys, fluorine formula is F2. Reaction with fluorine is much faster as compared to chlorine. Fluorine is much reactive as compared to chlorine. So this is how it is happening. Okay, so right now I'm going to take this is ethane. Now what was the formula of ethane? C2H6. How we know this thing that its formula is C2H6? It is the second member. H stands for number 2. H stands for number 2 when there are two carbon atoms. Ane means there is only carbon-carbon single covalent bond. So it is the second member of alkanes family, that is called as ethane, C2H6. Now, there is one more thing which you people should know, that there will be H's here. There will be H's here. This is H, and H along with this. Along with this reactant, there is another reactant F2 which is called as fluorine. Otherwise, guys, don't forget this thing that you people should write ultraviolet sign, ultraviolet radiations on the arrows as well. Oh my God, I just forgot to write here. So please, I am just saying you to write down ultraviolet radiations over there. Okay, so this is really very important. I have mentioned it here very clearly. If I'm moving on to this page back, guys, can you look at there right now? Okay, how many carbon atoms are there? Two carbon atoms. How many hydrogen atoms are there? Six hydrogen atoms. So how many steps will be there? Six steps. How many reactions will be there? Six reactions. How many times HF will being produced? Six times. What is the name of HF? It is called as hydrogen fluoride or hydrofluoric acid. HCl is called as hydrogen chloride or hydrochloric acid. So these are all different types of hydrogen halides. Okay, so right now I'm just saying this is C, this is one F, this is H, and the remaining H's will be as it is. Okay. Guys, one more thing which I would like to tell you, that either you are going to consider it as it this carbon as carbon number one, or this carbon as carbon number one. So there is no English side or no other language side. You people have this choice to select one carbon as carbon number one. But this will not happen. That in one of the reaction you are going to consider this as carbon number one, and in the second reaction you are going to consider this as carbon number one. No, no, no. If you are going to consider this as carbon number one, you will be remain considering this carbon as carbon number one. Okay, so please be careful about that. Okay, along with this, what is the other product? It is HF. Okay, so what is the name of this product? This product is called, let me write down the name. What is the name of this product? This product is called as 1 dash fluoro 1 fluoro. Okay, let me write it. Okay, 1 fluoroethane. Okay, 1 fluoroethane. And what is the molecular formula? C2H5F. 1 fluoroethane. Okay, now I'm changing the board. Okay, and what is this now? Okay, I am here. Okay, so this is C, and this is one of the F, and the H's are remain intact. And now we are going to continue this reaction with another F2. So it is C, and this is F, and there is another F, and there is H over there, and the H's are there as well. Here you can see the other product which is being produced is HF. You can see this is the reaction which is going to happen. So what is the name of this compound? It is 1 comma 1 dash difluoroethane. Okay, so there is no dash among the alphabets. There is a dash between a number and an alphabet, and there is a comma among the numbers. Okay, so this is called as the rules for naming. I'll bring your attention towards the rules for naming of organic compounds separately. Okay, so here, inshallah, I am bringing your attention to the next point. It is the product of the second one, which is the reactant of the third one. This is H here, and H here. Along with that, it is C and F are there already, and the H is here. So it is F2, which is going to react. So it is C, and F is here, F is here, F is here, and this is H here, and here. Okay, so this is how we are going to react, and this is the HF which is being produced. So what is the name for this compound, which is very important right now? It is 1 dash trifluoroethane. Okay, so I have replaced all the hydrogens of one carbon first. So I would like to inform you very clearly, you are going to replace all the hydrogens of number one first, and then you are going to move to the second one. Guys, such type of reactions in such a long detail will definitely not be asked from you people in your exam. Why? Because it is requiring time, it is requiring more space, and etc, etc. So examiner would like to judge you by asking a direct question. What will be the organic product? What will be the inorganic product? Write down the formula of the two products. So if you people have this practice, I would like to suggest you to make the practice with 2 or 3 alkanes stepwise, so that this concept may be fixed into your mind. Okay, so that you may not forget the basics of this concept. So that's why I'm practicing right now with you as well. So this is hydrogen fluoride along with the basic product. Okay, now I am taking you to the next one, and that is towards the second carbon atom. So this is this here. Let me bring your attention. This is this F here, and F here, and these are the H's here, and here. You people can see this thing that it is going to react with F2, and this is this, and these are the previously present F, already present F, and now it is O. Right now I'm going to write it with another color so that you people may have a clear idea. So this is this F now, and the H's will be remain there. Okay, along with this, what is the other product? This is again the HF. What is the name of this product? Okay, so this is called as uh, 1 comma 2. Yes. So this is carbon number 1, Its carbon number one has this, carbon number one has this, carbon number one has this. Now, this is the carbon number two. So this is carbon number one and this is carbon number two. Okay. So don't forget this thing that when we are talking about one, it means that we are talking about all of these three. And when we are talking about two, we are talking about this fluorine only. So this is 111, comma 2 dash tetra, tetrafluoro ethane. Along with this, hydrogen fluoride is a product. And then if I'm taking you to the next one, it is this right now. And here I'm saying this is this, and this is H, and this is F, the new F, and here these are the previously present, all those three. So this is F2. I'm taking you to the next one. So you can see it is C, C, F, F, and F here. This is the previously present. Here I'm going to write the new one with another color so that you people may not forget. So this is the H here, the only present, the only remaining H here. So this is HF. So what is the name of this? It is 11122. Now there are two fluorines on the second carbon. 2. So this is now penta. Pentafluoro ethane. Okay, so this is the product of this one. Okay, now I am taking you to the next one, the last one. Why last one? Because we are left with one hydrogens only na, so that's why it is the last step. Okay, so it is this. Now it is this, so it is this, and this is the fluorine here, fluorine here, fluorine, and this is the remaining H, and this is fluorine. Guys, so it will be reacting with F2, and now I am this C, C, F, and F here, and F here. Along with this is F, and this is F, and this is HF. Oh, yes. So what is the formula for this? It is can be called as C2F6. Yes. And what is the name? It is 11122 dash hexafluoro hexafluoroethane. As I'm shortening of space, so I'm writing here hexafluoroethane. So this is how this reaction is going to occur. This is the way of substitution reaction. This is the key of substitution reaction. These are the basic concepts of substitution reaction. And I would like to suggest you to make a practice of methane with either fluorine or chlorine. No doubt it can show a reaction with bromine as well, but the reaction with bromine will be very, very slow. Okay. So we already know this thing that in group number 17, the reactivity is getting lesser going down the group. And I have taught you the details of this, why reactivity is getting lesser by going down the group in group number 17, when I have taught you chapter of periodic table over there. So group number 17 are basically the non-metals. So non-metals have their reactivity based upon their ability to grab an electron, to gain an electron. So when their size will be enlarged, when they will have bigger size, obviously it will be difficult for nucleus to control the previously present electrons, how it can accommodate a new electron, how it can attract a new electron. That's why it is going to limit itself to the same number of electrons. That's why the reactivity is getting lesser by going down the group. So this is how we are facing this challenge of reactivity, that in case of group number 17, fluorine and chlorine are the most reactive. So you people are suggested to make a practice of methane and ethane with fluorine and chlorine. You people can make a practice with propane as well. Obviously, the propane formula is C3H8, so which has 8 hydrogen atoms. So it means that it is going to pursue with 8 steps. Okay, so this is how this reaction of substitution is going to happen. Okay, all the best to all of you. Thank you very much. I'm going to pursue this chapter of alkanes further with the next topic shortly, inshallah. Take care of yourself. Allah Hafiz.